Welcome to True Projects. In this video, we are going to explain about the project title, an empirical analysis of machine learning algorithms for crime prediction using stacked generalization and ensemble approach. Introduction. The project is focused on developing an effective crime prediction method termed the Ensemble Stacking Based Crime Prediction Method, SBCMP. This approach integrates support vector machine SVM algorithms and ensemble learning, particularly employing the stacking technique to enhance prediction accuracy. The primary goal is to respond to the increasing crime rates by conducting research in crime prediction and efficient control mechanism. The project underlines the limitations associated with manual handling of criminal records and underscores the importance of adopting novel approaches for analyzing crime-related information. The project places a specific emphasis on two crucial components of crime prediction: prediction of crime risk fields and forecasting crime hotspots. It aims to accurately predict areas with elevated crime risk fields, and foresee specific locations where criminal incidents are expected to be more concentrated, crime hotspots. Objective. The primary goal of the project is to create a user-friendly system capable for predicting crime rates. This system will utilize features provided by users to forecast potential crime occurrences. The objective is to assist law enforcement and communities in taking proactive measures to prevent criminal activities before they happen. The project integrates a variety of machine learning algorithms, including linear regression, SVM, Navy-based decision tree, support vector machine, bagging regressor, stacking regression, random forest, and KNN. Each algorithm contributes a distinct approach to crime prediction, providing a comprehensive analysis of historical crime data. The project aims to comprehensively analyze historical crime data using a diverse set of machine learning algorithms. By employing these varied algorithms, the goal is to extract meaningful patterns and insights from the historical data. This approach allows for a thorough examination of past crime occurrences, aiding in more accurate predictions and proactive crime prevention strategies. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of project. To implement this project, we have designed the following modules. The first module is importing the packages. This module involves importing essential software libraries and packages into the project environment. These libraries typically include tools for data manipulation, analysis, visualization, and machine learning. For example, in Python, commonly used packages include pandas for data handling, NumPy for numerical operations, and scikit-learn for machine learning tasks. This step is vital as it ensures that the project has access to necessary tools for data analysis and model development. Exploring the dataset. In this module, the project focuses on understanding the dataset that will be used for crime prediction. The dataset is typically loaded and initial exploratory data analysis (EDA) is conducted. EDA involves tasks like reviewing the structure of the dataset, examining data types, identifying missing values, summarizing statistics, and gaining insights into the features and target variables. Understanding the dataset is fundamental for making informed decisions during data pre-processing and model building. Data processing. This module involves preparing the dataset for further analysis and model training. Tasks include handling missing data, cleaning data, transforming features, encoding categorical variables, and scaling numerical attributes. Data pre-processing ensures that the data is in a suitable format and quality for machine learning models. Properly processed data can lead to more accurate and reliable predictions. Visualization using Seaborn and Matplotlib. In this module, data visualization techniques are employed using Seaborn and Matplotlib, popular Python libraries. Visualizations such as histograms, scatter plots, heat maps, and bar charts are used to present patterns and relationships within the data. Visualization helps in gaining insights into the dataset, identifying trends, outliers, and correlations, aiding in better understanding and decision making during the modeling phase. Splitting the data to train and test. This module involves dividing the dataset into training and testing sets. The training set is used to train machine learning models, while the testing set remains unseen during the training phase and is used to evaluate model performance. Splitting the data allows for an unbiased assessment of the model's predictive capabilities and helps prevent overfitting, ensuring the model generalizes well to unseen data. Building the model, in which we have different algorithms. The first algorithm which we have used is linear regression. Linear regression is a foundational regression algorithm that aims to establish a linear relationship between the input features and the target variable. In this context, it is used to predict crime rates based on various features like demographic data, economic indicators, or other relevant factors. SVM with sequential minimal optimization (SMO). Support vector machine is a powerful classification algorithm, and the sequential minimal optimization (SMO) is an optimization algorithm used to train SVM. SVM can be applied for crime prediction by defining a boundary that separates different types of criminal activities based on features like location, time, and other relevant parameters. Navy-based regression with linear modeling. Navy Bayes is a probabilistic classification algorithm based on Bayes' theorem. It's efficient and works well with high-dimensional data. The linear model aspect implies the assumption of a linear relationship between features and crime rates, making it applicable for crime prediction tasks. Decision tree. A decision tree is a flowchart-like structure where each internal node represents a feature or attribute. Each branch represents a decision rule, and each leaf node represents an outcome. It's a versatile algorithm used for both classification and regression tasks, making it suitable for predicting crime occurrences based on various factors. Support vector machine. Bagging regressor. Bagging, short for bootstrap aggregating, is an ensemble technique. A bagging regressor involves training multiple instances of model decision tree on different subsets of the dataset. The final prediction is the average of the predictions from all the models, which often leads to improved prediction accuracy and stability. Stacking regression. Stacking is an ensemble learning technique that combines multiple Bayes models using a meta model. The meta model learns how to best combine the predictions of the Bayes models. It's designed to improve predictive performance and robustness by leveraging the strengths of different models. Random forest regressor. Random forest is an ensemble learning method that consists of a collection of decision trees. It aggregates the predictions of individual trees to produce a final prediction. Random forest is highly effective for regression tasks and provides robust and accurate predictions. KNN, K nearest neighbor. KNN is a simple and effective algorithm used for both classification and regression. In regression, it predicts the output based on the average of the K nearest neighbors' values. In this project, KNN predicts crime rates based on similar historical patterns and features. Training the model. This module involves the process of training the machine learning models using the prepared and pre-processed dataset. Models such as linear regression, SVM, decision tree, random forest, and others are trained on the training dataset to learn patterns and relationships between the features and the target variable. Training involves adjusting model parameters to minimize the difference between predicted and actual outcomes, ultimately optimizing the model's predictive performance. Flask framework with SQLite for sign-up and sign-in. Flask is a lightweight web application framework in Python, and SQLite is a self-contained, serverless, and zero configuration database engine. In this module, Flask is employed to create a web application where users can sign up and sign in. SQLite is used as the database to store user information securely, allowing for user authentication and authorization within the system. User gives input as feature values. In this step, users provide input to the system in the form of feature values. These features could be related to specific attributes such as demographics, location, time of day, economic indicators, or any other relevant information that the machine learning models require to make predictions. The given input is pre-processed for prediction. The input provided by the user needs to go through pre-processing, similar to the data pre-processing done earlier with the dataset. This ensures that the input features are in the right format, encoded and scaled appropriately, making them suitable for prediction using the trained models. Trained model is used for prediction. Once the user input is pre-processed, the trained machine learning models are utilized to make predictions based on the pre-processed feature values. Each model predicts the crime rate based on the provided input features. Final outcome is displayed through front end. The final predictions from the machine learning models are then displayed to the user through the front end of the application. This front end interface is part of the web application created using Flask, allowing users to view the predicted crime rates or related outcomes based on their input. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. Here I am typing python space app.py. This command will execute the Python script and perform a runtime check for any syntax error or logical issues. Now hit enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is this, and port, which is this. Now copy this local link. I am copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The home page of the project is displayed in the browser. This is the front end built using Flask framework. So here, click on sign up. If we are a new user, we need to register first. But I have already registered, so click on sign in. Enter the username and the password which we have created and click on sign in. This is the home page of the project. So now click on predictions. So this is the predictions page. Here we can see we have 4 types of predictions here: crime against women, crime against children, IPC crimes and SLL crimes. So now click on crime against women. So here we need to select the year, crime type and state of the choice for appropriate predictions. So I'm selecting the year as 2018 and I'm selecting the crime type as assault on women and I'm selecting the state as Jammu and Kashmir. Now click on submit. So here we can see we got the graph for assault on women. So here we can see on the x-axis we have the year and on the y-axis we have number of crimes. So here we can see in the year 1990 we are having total 327 cases on assault on women, and in the year 1998 the total cases on assault on women is 516, and in the year 2012 the total cases is 1322, and in the year 2018 the total cases is 1508. So from this graph we can say that every year the cases are increasing on assault on women in Jammu and Kashmir. So we are having the cases from 1990 till 2018. So we can say that the cases are increasing. Now let us select the year 2019 and let us select the crime type, that is rape, and the state, all states, and click on submit. So here we can see we got the graph for rape cases in India up to year 2019. So on the x-axis we have years and on the y-axis we have number of crimes, and we are having the cases from the year 1990 till 2019. So let us see, in the year 1990 the total rape cases is 9,518, and in the year 2012 the total rape cases is 24,923, and in the year 2019 the total cases is 34,497. So we can see that each year it is increasing, and the highest count is in the year 2016, that is 38,947. Now let us select the year, and the crime type is kidnapping and abduction, and the state is Haryana, and click on submit. So here we can see we got the graph for kidnapping and abduction cases in Haryana up to year 2019. So on the x-axis we have years and on the y-axis we have number of crimes. So we can see we got the cases from the year 1990 till year 2019. So here we can see in the year 1990 the number of cases were 131, and in the year 2013 the number of cases is 1957, and in the year 2019 the number of kidnapping and abduction cases is 3,330. So here also we can see that each year it is increasing. The number of kidnapping and abduction cases is increasing each year. Now let us select the year. Let us select the crime type, that is dowry death, and the state, all states, and click on submit. So this is the graph for dowry death cases in India up to year 2020. So we are having years on the x-axis and number of crimes on the y-axis. So here we can see in the year 1990 the number of dowry death is 4,836, and in the year 2007 the number of dowry death cases is 8,093, and in the year 2020 the number of dowry death is 9,285. So here also the dowry death cases is increasing each year. So we have this till 2020. Now let us select the year and the crime type and the state and click on submit. So here we can see that data is not suitable for prediction. So let us select the correct data. And click on submit. So here we got the graph for insult to the modesty of women cases in Andhra Pradesh up to year 2019. So here on the x-axis we have the years and on the y-axis we have number of crimes, and we got the insult to modesty of women from 1990 till 2019. So here in the 1990 the number of cases is 1056 and the number of cases in 2010 is 4562 and the number of cases in 2019 is 4506. So here we can see there is the sudden increase and decrease of the insult to modesty of women in Andhra Pradesh. So in the year 2013 we have the highest count, that is 4702, and the lowest is in the year 1994, which is 371. Now let us select the year and the crime type and the state and click on submit. So here we can see we got the graph for cruelty by husband or relative cases in Assam up to year 2020. So on the x-axis we have years and on the y-axis we have number of crimes. So here we can see that in the year 1991 the number of cases is 199, and in the year 2015 the number of cases is 11,225, and in the year 2020 the number of cases is 9,445. So we can see there is a sudden increase and then a decrease in the crime count. So now let us select year and the crime type again and the state and click on submit. So here we can see we got the graph for total crimes against women cases in India up to year 2017. So on the x-axis we have the years and on the y-axis we have number of crimes. So here we can see in the year 1990 the number of crimes against women is 68,317 and the number of crimes in the year 2016 is 3,38,954. So we can see there is a sudden increase in the total number of crimes against women. So in this way, by entering the year and selecting the crime type and the state, we can get the graph for the particular crime. Now click on crime against children and select the year, crime type and state. So I'm selecting the year as 2020 and the crime type is and the state and submit. So here we can see we got the graph for buying of girls for prostitution. So here we can see on the x-axis we have the years, and on the y-axis we have number of crimes. So we can see that in the year 1996 the count is 17. This is the only count which we have. Now let us select 2017 and the state and submit. So here we got the graph for feticide cases in Bihar up to year 2017. So on the x-axis we have the years, and on the y-axis we have number of crimes. So here we can see in the year 1994 we don't have even a single case on feticide, and again in the year 1995 we are having 2 cases, and in the year 1996 we have 5 cases. In the year 1997 4 cases. So it has decreased from 5 to 4, and again it has decreased from 4 to 2, and again it has suddenly increased in the year 1999 from 2 to 4, and again it has decreased in the year 2002, that is 1, and in 2001 there is not even a single case, and in 2002 again we are having 1 case, and in the year 2009 we have 5 cases, and in 2007 we don't even have a single case. So here we can see the fluctuations, that it is increasing and suddenly it is decreasing. Till 2017 we can see lot of fluctuations. Now let us select the year and the crime type and the state and submit. So we got the graph for exposure and abandonment cases in Jharkhand up to year 2019. So on the x-axis we have the years, and on the y-axis we have number of crimes. So here we can see that in the year 1994 till 2006 we don't even have a single case for exposure and abandonment, but in the year 2008 we have a single case, and again in the year 2011 we are having 1 more case, and till 2019 we don't have a single case for exposure and abandonment. Now let us select the year and the case type and the state and submit. So we got the graph for Prohibition of Child Marriage Act 2006 cases in Assam up to year 2020. So on the x-axis we have years, and on the y-axis we have number of crimes. So here we can see in the year 1994 we only have 1 case, and in the year 2020 we have 42.755 cases. So we can see there is the increase in the number of cases. So in this way, by selecting the year and the crime type and the state, we can get the graph of the particular crime, and we can see the changes which are happening in the country. Now click on IPC crimes, select the year and the crime type and the state and submit. So here we have the graph for dowry cases in Gujarat up to year 2017. So on the x-axis we have the years, and on the y-axis we have number of crimes. So we can see that in the year 2001 the number of dowry cases is 67, and in the year 2004 the number of dowry cases is 58, and in the year 2017 the number of dowry cases is 5.92. So we can see that there is the decrease in the dowry cases. Now let us select the year and the crime type and the state and submit. So we got the graph for cheating cases in Haryana up to year 2020. On the x-axis we have the years and on the y-axis we have number of crimes. So here we can see in the year 2001 the number of cheating cases is 1016, and in the year 2016 the number of cheating cases is 3155, and the number of cheating cases in the year 2020 is 3110. So we can see that the cases are increasing as well as decreasing. So we have a fluctuation here. Now click on SLL crimes. Now select the year and the crime type and the state and submit. Now click on submit. So we got the graph for Prohibition Act cases in Gujarat up to year 2018. So here on the x-axis we have the years and on the y-axis we have number of crimes. So here in the year 2001 the number of Prohibition Act cases is 1,12,114, and in the year 2018 the number of cases is 2,69,948.86. So we can see there is the increase in the number of cases of Prohibition Act. So in this way, by selecting the year, crime type and the state, we can get the graph for the particular crime type and we can see the changes. We can see the fluctuations of each crime type, whether they are increasing or decreasing. The conclusion of the project is the project achieved a notable high accuracy in predicting crime using the proposed assemble stacking based crime prediction method SBCPM with SVM algorithms and ensemble learning. This indicates the effectiveness of combining SVM with ensemble learning for crime prediction. The stacking ensemble model showcased better prediction accuracy than using individual classifiers alone. This underscores the advantage of ensemble learning, especially stacking, in improving predictive performance by combining diverse models. The project aims to aid in reducing crime rates and deterring criminal activities by utilizing machine learning and ensemble techniques for crime prediction. This approach empowers law enforcement and policymakers with insights to proactively prevent crime and allocate resources efficiently.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.